Hello, boys and girls. Let's look at lesson 12-3, ratios. Okay, what is a ratio? Let's identify it. Down here we have the definition. Okay? A ratio uses division to compare two counts of measures. So we're comparing, it's like we're writing a fraction, okay, like a division. And we're going to compare two counts of or measures having the same unit. Okay, the same unit. Ratios can be stated or written in a variety of ways. Sometimes a ratio is easier to understand or will make more sense if it is rewritten in another form. Ratios, for example, boys and girls, let's look at this one. On an average evening, about 1/3 of the U.S. population watches TV. And on an evening, 1/3 of the population, that's about 160 million people. That's a ratio, saying they use a fraction to express how much of the population, the U.S. population, watches TV. Another one, elementary school students make up 14% of the U.S. population. 14%. Here we're using another ratio, but this time we're using percent out of 100%. 14% out of the U.S. population are elementary school students. And if we had to rewrite that, sometimes we can use words. Let's go down here. Let's go to the second part of this page. On this side, we can see how ratios are written differently and how they use words, fractions, percents to express, and even written using a colon. Okay, so let's see. 2 out of 10 students are left-handed. 2 out of 10. I would write 1 in 5, but 2 out of 10. 2 in 10 students are left-handed. The ratio of left-handed students to all students is 2 of 10. These are all using words. Okay, again, I was right, 1 in 5. With a fraction, 2 out of 10 or 1 in 5 of the students are left-handed. With percents, well, 20%. 1 out of 5 is 20% of the students are left-handed. And using a colon between the two numbers being compared, the ratio of left-handed students are 2 to 10. 2 for every 10. Okay, let's practice down here writing them using the words. Okay, let's see. With words, students are right-handed. How many students are right-handed? Well, we were told up here how many are left-handed, right? Well, what's left over? If you're saying 8 out of 10, you are correct. Or let's just write in simple format, 4 out of 5. 4 out of 5 students are right-handed. With a fraction, well, we can write 4 out of 5 students are right-handed. With a percent, this would be 80%. 80% of students are right-handed. And with a colon, let's shift this over so we can see it. Okay, with a colon, the ratio of right-handed students to all students, for every 8 students, colon, out of 10. 8 students out of 10, or we could also write 4 students out of 5. You choose what you like. I always like to go simplest. This is the simplest. This is the simplest format. Okay, let's go to the next page. On page 405 of the Math Journal, we have to use the student reference book. Let's save this page for class. We will do it with our elbow buddies or a partner, however we decide to choose. But we definitely need the student reference book so that we can answer this question. We will do it in class. Next page. On the next page, we're going to look at magnitude numbers or using ratios to compare. We do this all the time, boys and girls. Sometimes we want to tell a story and we exaggerate, so we'll say something is 10 times bigger, or sometimes we'll just simply say, oh no, it's only a little bit, it's a fraction, maybe a tenth, 1/10 of the size. Wow. Let's see, let's read together. Have you ever heard or used expressions such as 10 times as many? Or 1/10 as much? These are ratio comparisons. Be sure to use expressions like these with caution. Be careful. You never want to change something by too much. When you say something is 10 times more, you're really saying it's a lot more. Increasing or reducing something by a factor of 10 makes a big difference. Scientists call a difference of 10 times an order of magnitude. Big, magnitude, large. And they believe that the world as we know it changes drastically when something is increased or decreased by a magnitude. Let's see an example. A person can jog, okay, they run about 5 miles per hour. 5 miles per hour, that's pretty fast for jogging. A car can travel 10 times as fast as that. So if 10 times this number per hour, that means 50, because 5 times 10 is 50. So a car can travel 50 miles per hour. That's true. A plane can travel 10 times as fast as a car. So from 50, we jump up to 500. That's a big jump, from 50 miles an hour to 500 miles an hour. Each magnitude increases in travel time speed has a great effect on our lives. So let's complete the table below. Here we have to do both, okay? We have the event, what's happening, length of math class. Well, our math class, boys and girls, is exactly 1 hour and 10 minutes, I believe. Let's see, we start at 10:15. Yeah, 1 hour. Put it 1 hour and 10 minutes. Oh, that almost looks like a ratio using a semicolon. We don't want to make it look like that, so let's change that. There, that's a bit better. 1 hour and 10 minutes. Well, what is this in 10 times more? Oops. 10 times more. What is it? How many hours and how many more minutes? 10 times. And then what is 1/10 of this? Okay, now you're going smaller. Here you go larger, 10 times the size, 10 times as much. And here, only a fraction of this, 1/10 of 1 hour and 10 minutes. Number of students in math class. Number of students in math class. Well, we have 20 students in our classroom. This one should be easy to work with. Okay, so 20 students. And length of your stride. How long is your stride? Mine is just under a meter. A meter is 100 centimeters. My strides are about 80 centimeters. Okay, you can use your own stride here. Probably a little shorter than mine. And then write 10 times as much or 1/10 as much. And then for the last two, I want you to use your own. Find your own for these two. This one and this one. What can you compare? And then write 10 times as much. Perhaps you could do how long it takes you to come to school from home. It could be a 10-minute ride, a half an hour ride. And another one, perhaps how much TV you watch in 1 week. Those are just suggestions. I'd like to see what you have, what you come up with, and you can also use mine. For our additional piece today, rather than giving you a joke or a quote or a riddle, I will give you an interesting fact. And I know how much you guys enjoy Albert Einstein, so here's the fact. Einstein was a quiet kid in his early years of childhood. While talking, he used to pause often for long, awkward periods of time. This happened until he was about 9 years old. His parents felt worried whether their child was a below-average kid. So, they thought Einstein was not quite smart because he would pause for a long time and it was awkward because he would stop midway through sentence. Well, this goes to show, boys and girls, do not judge a book by its cover. See you in class.